Okay, so here we are with our Exam 3 review for History and Systems of Psychology. So as usual, we will have both the essay component to the exam, 2 essays worth 20 points each, as well as 30 multiple choice questions in the other part. In this unit, we've covered chapters 11 through 14, basically the history of psychology as it emerged in the United States at the end of the 19th century and the modern history of experimental psychology through the 20th century, focusing on behaviorism and cognitive psychology. So first up, we had in chapter 11 Darwin and other evolutionary theories. We covered kind of the basics of what these theories are all about, but we were also focusing on how these theories in particular had an effect and an influence on psychology. So we talked about actually two prominent theories in evolution. The first was the ideas of Jean-Baptiste Lamarck, whose ideas ultimately were superseded by those of Darwin, but we focused on Lamarck because Lamarck had and continues to perhaps still have some influence on the way people think about evolution and the way in which it has been interpreted within some areas of psychology as well. So what we want to know about Lamarck are two things. One, and most importantly, I think, for our purposes, is that Lamarck's theory represents what is known as a teleology, right? A teleology is any idea that supposes there is a purpose behind whatever the idea is all about. In this case, the idea is about evolution, and so a teleological theory of evolution is one that supposes that there is a purpose to evolution. And as we talked about in those notes, for Lamarck, the purpose is about a gradual improvement in each species generation after generation. This is where the inheritance of acquired characteristics comes in. The idea is that any given generation of a species has inherited the characteristics of its parents, but is able to improve on them, even if it's just by a fraction. And that fractional improvement is then passed on to the next generation beyond that. So now this third generation has inherited, again, a slight improvement from its parents, and therefore it's just continues to build and build and build. Each species kind of now evolving towards some idea of a perfection of the species. That's the teleological part, is that there is in fact some sort of an end goal to evolution, that every species has in its future some sort of perfection, and that evolution is a gradual improvement toward that end. With Darwin's theory, on the other hand, we see something that's very different. There is no teleology in Darwin. The idea is there is no end goal, and evolution is not just a continuous process of improvement. The idea is that evolution really is about maintaining adaptation and fitness to the environment. And based on changes in the environment, whether it's through animals moving their environments or the environment's changing or just generally competition for limited resources, then evolutionary change could be accelerated. But in other situations where everything is stable and there is less competition for limited resources, then evolution would in fact be very slow, if even not even occurring very much at all. So in this case, the goal, if there is any, is really just about maintaining fitness, but there's no kind of absolute definition of what fitness means. It's a function of the animal and their relationship to their environment, to their ecological niche or ecosystem. When we talked about how these ideas affected psychology, we talked about some of the ideas of Herbert Spencer, and one of those is called the Spencer-Bane principle, in which Spencer applied evolutionary thinking to learning, and he borrowed from Alexander Bane. Again, just review back to Alexander Bane's ideas in chapter 5 about learning by association. But what Spencer is doing is saying that, okay, this ability that we have to learn by association is something that has evolved. It has adaptive value. Something as simple as saying that we can learn the consequences of our actions, and that helps us survive, helps us maintain fitness and adaptation to the environment. That is consistent with evolutionary thinking. It also had suggested, and down at the bottom I have this listed here, that this leaves us the possibility of a comparative psychology. So Darwin had taken a step in this direction by placing humans in the animal kingdom with the rest of animals and suggesting that Homo sapiens is derived from other kind of a primate line. And so in that sense, there's continuity within the animal kingdom. And what Spencer has done here is he's placed psychological properties like learning as part of our biological makeup. And that means the study of these psychological things are really biological things. And given the evolutionary continuity of our biology, the same now applies to our psychology. And that then implies that the mechanisms of learning in other animal species could be comparable between humans and those other animal species. And that is, in fact, a new idea in the 1800s. Prior to that, it had been assumed that the human mind was special because of our capacity for reason and logic, the rationalist ideas of the past, especially of Descartes, who believed that humans had free will and that animals were more robotic. So that did not allow for a comparison between human and animal psychology, but these new ideas do. In the middle here, we have another of Spencer's ideas known as social Darwinism. Now, again, I want to emphasize that that is not a term that Spencer used, nor did anyone use in that time frame of the 19th century. It's rather a mid-20th century term that is applied to the ideas of people like Spencer as well as others that he influenced, such as Galton. And the basic idea here is that and in reality, also, this idea is a little bit more Lamarckist than it is Darwinist in nature, but nevertheless, the idea of calling it social Darwinism was applied and it stuck. The name stuck, so that's what we're left with here. But the basic idea, since it's based on more of a Lamarckist thinking of gradual improvement of a species over time, and that as applied to humans means gradual improvement of our intelligence from generation after generation, and that those who are more intelligent achieve more success in life, and that then means that they also will be more likely to have more offspring and pass on that intelligence to their offspring. And so people who are successful and intelligent are so because of their family lineage. There's also the corresponding idea that the overall quality of a society is determined by the successful, intelligent people who are running it. And so if we want to improve human society and achieve another kind of teleological idea of a future human society that is perfect and ideal, aka a utopia, then we would want to improve human intelligence. And that's where the idea of eugenics comes in, that we could, through various selective breeding programs or even something a little bit more impactful than that, we could modify human intelligence to improve it in the long run. That would be the goal. But of course, to understand the nature of human intelligence and to also understand whether it is a inherited thing or whether it's something that is learned, has now spawned the onset of mental testing research, psychometry, as we had talked about it, intelligence testing. And so here we see the beginnings of a nature-nurture debate as applied to psychological traits. The nature-nurture debate mirrors the philosophical stuff of rationalism versus empiricism that we've been talking about throughout this class, but specifically applied to psychology when we think about things such as intelligence or personality traits or anything that goes into our psychological makeup. The idea of either it's your nature, you were born that way, it's genetically predetermined perhaps, or it's in your nurture, that is, you're born a blank slate, and everything about your psychological makeup occurs as a function of your experience. That's the origins of this debate. And as usual, when it comes to these kinds of things, in modern time, we see that the answer is really more like it's got to be both, nature and nurture. But in the beginnings, it was very much a nature versus nurture debate. When it's specifically applied to intelligence and measuring intelligence as IQ, and we've talked about why that's a problematic idea, at least as historically defined as the ratio of mental age over chronological age. That's a problem because this idea of the rate at which your mind develops could somehow be independent of the rate at which your body develops chronologically is very much a dualistic way of thinking about things, and that doesn't make any sense. nowadays IQ is defined in a completely different way, but that's the historical origin of it. But when we asked what goes into it, what is IQ actually measuring, we talked about the idea there could be something like a general overall intelligence that just kind of gives you an overall, overarching kind of intelligence that gives you the ability to do anything you set your mind to doing, versus the possibility that we don't have that, but rather we just have skills in very specific domains, and that those skills could all be different across many different domains. You could be good in one thing, but not so good in another. That then affects, of course, the nature of an intelligence test, and whether an intelligence test should be trying to measure these overarching aspects of intelligence, or whether it should be focusing on a bunch of domain-specific skills. And then there's also some debate about whether other kinds of things should be included in IQ tests. So this is where those who take a nature perspective have really focused on the idea that if it's in your nature, then it should correlate with other aspects of your biological and physiological stuff. So Galton's anthropometry research, measuring the body, of course, harkening back to Gall, and phrenology is measuring the head, craniometry, big brain equals more IQ was the thinking. But then Galton also had these ideas that other physiological tests, that like the early neuroscience measurements, reaction times, and psychophysics stuff that we covered back in Chapter 7, and the origins of neuroscience and physiological neuroscience, that those things all reflect an efficient brain, and that's a big part of his intelligence concept. So all of these things have ultimately been shown, these physiological measures at least, were shown to not actually correlate with the more traditional measures of IQ and have been discarded, but they were part of the debate at the time. Now, in Chapter 12, in Chapter 12, we looked at the beginnings of psychology in the United States, and we talked a lot about William James, who is kind of considered the first American psychologist, though it is important to realize that he was not an experimenter. He was really more of a writer and a teacher and a theorist. So at Harvard University, he created a psychology program there, teaching psychology within the philosophy department, and wrote his big book, really the first textbook in psychology, Principles of Psychology. And some of the key ideas that he covered in there was the concept of the stream of consciousness, and how, according to this idea, you cannot really reduce consciousness down into bits and pieces. You can't freeze it and study it. It's more of a continuous stream. So just like it doesn't make any sense to analyze a stream or a river down into its bits and pieces, it doesn't make any sense to do that kind of thing with the mind. So like many others, James is an anti-reductionist. We've seen that before. We've seen that the phenomenologists of Chapter 8 and the Gestaltists of Chapter 9 do not like reductionism in psychology. And we have also seen, and we'll get to the functionalists later in this chapter, they also, mainly because of their influence by William James, do not like the reductionism of people like Tishner. James also had his theory of emotion, sometimes referred to as the James Lang theory of emotion, because of its another person who came up with the same basic idea, which is an empiricist theory of emotion, that our emotions are the functions of our sensory processing of internal bodily states. And then James's philosophy of pragmatism is influenced by Charles Sanders Peirce, that the truth of an idea can be determined by its practical value, and how he used this kind of thinking to support an argument for free will as part of the free will versus determinism debate. Now, in terms of who we would want to consider to be the real first experimental psychologist in the United States, that honor goes to Granville Stanley Hall at Johns Hopkins University. He was the first American to go to Wundt and get an actual psychology PhD, and then he came back and created the first psychology lab in the United States at Johns Hopkins University. And as a pioneer in developmental psychology, he's known for a lot of things related to adolescence and aging psychology and the study of genetic influences and development. But for our purposes, we're mostly interested in him as the so-called great organizer in psychology, as creating the APA and creating the first psychology journal, the American Journal of Psychology. That's the first psych journal printed in the English language, at least. And also just his role as an administrator, because after a few years at Johns Hopkins, he was hired away by Clark University and became president of Clark University. And we also had looked at some of the racial and gender biases in early science and especially psychology, and we talked about Frances Sumner as the first African American to get a psych PhD, and Margaret Floyd Washburn as the first woman to get a psych PhD, and the story of many other important women in early American psychology. Now, the earliest school of thought in American psychology was right here, this new ism, functionalism. One of the things we focused on was the Darwinian influence, that just like with Darwin's theory of evolution, that animals have to adapt to their environment, the functional psychologist kind of viewed the mind as a way in which we can adapt to our environment, the things that happen within the mind. So just like the Spencer-Bane principle, learning helps us adapt to our environment. Certainly there's some adaptive value in learning the consequences of your actions. If you eat some red berries and they make you sick, you learn not to eat those again, right? That has survival value. But then the functional psychologist kind of viewed the whole rest of the mind as well. Human intelligence and personality and memory and learning and perception and all of the components that make up our psychological stuff, it all has some adaptive function. So Dewey talks about the mind as an instrument or a tool that we use to help us adapt to our environment. He also took an anti-reductionist approach to explaining reflexes. So when we talked about the child candle reflex there, he's basically saying that it doesn't make any sense to try to break it down into stimulus and response, as if those two things could be two separate things, and that you have to look at the overall action to understand the meaning of it and what the child has learned by reaching out to touch the candle and feeling the pain and learning not to do that again. And again, there's adaptive value in learning the consequences of your action. In that case, don't put your hand in the fire anymore. Other functionalists like James Roland Angell and Harvey Carr, again, they talked about the mind as a tool, and again, Angell said that the job description for psychology is to, or I should say that the goal of psychology is to create a job description for the mind, right? What are the various uses? One of my favorite analogies here is to think of a Swiss Army knife, and just to imagine that just like a Swiss Army knife has a bunch of different tools in it, and you can pull any one of those tools out to activate it and to use it for various reasons. The same is true of the mind. The mind could be seen as some sort of a hodgepodge of various tools and functions that all will help us achieve some end or some goal at any given moment in time. And our goal as psychologists is to figure out what are all of those specific functions. And this also could help us understand how and why psychology became as specialized as it did. You know, all of these separate areas of research into, say, memory and learning and motivation and emotion and perception and social psychology and all of these different subdivisions and all the different classes even that you can take in psychology. A lot of that has to do with the functionalist influence of wanting to study all of those functions. Harvey Carr defined the adaptive act, right, as kind of the basic action that any animal will engage in, that we need to understand how an organism is always trying to find its needs in the environment, to explore its environment based on its motivations, and to find a way to satisfy those needs in the environment. Woodworth extended the concept of motivation to explain how it works as a driver of our behaviors, and how that also plays a role in the mind here to mediate between the environment and our behavior. So this is where we get the idea, the functionalist idea of the SOR chain. So again, S for stimulus, O for organism, and by that we really mean the mind of the organism, and then R for the response. And so as opposed to a more behavioristic idea of just the mindless stimulus response chain, the functionalists are willing to put the mind in between there. The mind mediates between the stimulus and the response. We receive stimulus from the environment, then we think about it, and based on our motivations, based on our needs, we will then choose a response that will satisfy those needs. On into chapter 13, we started looking more at comparative psychology, and some of the early researchers, again influenced by Darwinian thinking here, that it is becoming more acceptable to study animal behavior and to try to draw some parallels between animal behavior and human behavior. First up is Romanes, who did not take a very scientific approach. So his anecdotal methods involved just observing animal behavior and then being somewhat anthropomorphic and applying human-like interpretations on that behavior. His student Morgan came up with his response and rebuttal to that with his guideline for interpreting animal behavior that came to be called Morgan's canon, which basically just means keep it simple, right? So he asks us to imagine something like a continuum of behavior. So there's simple kinds of behaviors, things that could be explained in very, very simple terms, such as a reflex. And then there could be more complex behaviors that might involve more complex mentalistic kinds of explanations, language perhaps being one of those things. And then there's perhaps a whole continuum in between. And therefore we have a spectrum of behaviors that range from very simplistic things to much more complicated things. And for Morgan, his argument is that you should always use the simplest explanation that is sufficient to explain whatever behavior you're talking about here. So the idea is that maybe some behaviors could be explained in those simplistic terms, but others perhaps not. And this is where we encounter the debate between two biologists, Loeb and Jennings, because what Loeb is saying is basically he believes that all behaviors will ultimately be explainable at the simplest level. So we don't even need to worry about this whole spectrum of explanation, and that you just need the simplest level of explanation, which is the reflex. And he talks about tropisms, these light-directed reflexes, moths flying towards the flame and plants growing towards the sunlight, all as examples of goal-directed behavior in animals that don't either have a very simple nervous system or even no nervous system whatsoever in the case of the plants, right? So his argument is that all behaviors can be reduced down to some kind of reflexive action. But Jennings is talking here about learning, and he says that learning is something that can't be explained using a reflex, because reflexes are fixed, and learning involves changing behavior over time. And if behavior is changing, he says that you can't use the reflex to explain it. Thorndike then set about studying learning, and he gives us the law of effect as he studied cats in these puzzle boxes that he invented. And here his argument is that the cats are motivated to escape the box because they're hungry and there's food outside the box, and that they learn that if they perform a certain response that they can have that need met, and he calls that a reward. And so because of the psychological need that they have to get to the food, they will learn to repeat this behavior to get what they want, that is, to get a reward. So there's a very psychological level of explanation involved in explaining why the cats would escape the box here. And we can see that Thorndike is a functionalist as a result of that, referring to the idea of the mind of the cat and the SOR chain mediating between the cat's environments and its needs here. In this case, its need to get to the food. And then the cat is learning various responses. But Pavlov, on the other hand, gives us something very important, right? We learn Pavlov's theory of how a reflex can be triggered by a different stimulus over time as a function of learning, right? So we start with an unconditioned stimulus followed by the unconditioned response, such as the dog salivating to food. But then, as he showed famously, that the salivation reflex could be transferred to a different stimulus entirely, in this case the clicking of a metronome. So what we see here is that reflexes are not actually fixed, contrary to what Jennings was saying, and that reflexes can change over time as a function of learning, and that's an important thing to set us up for behaviorism. But before I move to the next slide, I just want to emphasize that you should be able to, for this exam, be able to map out all of the chain of events in Pavlov's discovery. So understanding that we start with the unconditioned stimulus followed by the unconditioned response, such as food is followed by salivation, and then you pair the unconditioned stimulus with a neutral stimulus. So in Pavlov's experiment, that was pairing the food with the clicking of a metronome. And then after enough repetitions of that, the neutral stimulus becomes a conditioned stimulus, which is then followed by a conditioned response. So in this case now the metronome is followed by salivation. Salivation has become a conditioned response, whereas previously it was an unconditioned response. If you can do that for Pavlov, maybe also do that for this guy over here, Watson, and the Little Albert study, because that was the important thing that Watson did as he discovered Pavlov and realized that we could now explain learning in reflexive terms, which he used as the motivation to create this behaviorist idea The whole behaviorist manifesto that he wrote was inspired by this idea that we could explain behavior in these kinds of simple terms. It also helps that he was a student of Jacques Loeb, so we see that inspiration coming from there too. But famously, Watson was the first to apply Pavlov's technique to a human in the Little Albert study, showing that the fear response is effectively a conditioned reflex. And we also see the importance of science here, the idea of positivism as telling us that we can only really make a scientific study of things that can be observed. And a lot of the mentalistic ideas of the functionalists and even of the German psychologists were not about things that could really be observed in any objective way, whereas Watson is saying that what we can observe is the stimulus and the response. So we need to take the mind out of the SOR chain and just talk about the S and the R, because we can make a science out of that. Next in this chapter, the neo-behaviorists are some of the ones who begin to change the way we think about science here. So this is correspondingly in the 1920s, there's a new definition of science emerging, that instead of pure positivism, which focuses on just what can be observed, logical positivism allows us to go beyond observation. And that means, in the case of science, of having theories, right? A theory is a more general statement that goes beyond the data somewhat. And that's important for science, because science does need theories. But we need to have a way of distinguishing a scientific theory from just any old theory. And that was something that we previously did not have. And this is why, for example, even Hume's ideas way back in chapter 5 presented a lot of problems for science, because it kind of implied that we can't have theories, right? Theories are always unscientific if you're following Hume's position. But the logical positivists give us an alternative, and they say that theories can be scientific as long as they meet these certain criteria, but that they are logical. But what do we mean by logical? It means this idea of hypothetical-deductive reasoning, right? And this means that using deductive logic, a theory should generate a hypothesis that can be tested and then verified through experimentation. And this important principle of deductive reasoning towards a hypothesis and then verification of the hypothesis was a big part of logical positivism. We also saw Karl Popper kind of extend this and say that he was not satisfied with verification, but rather he felt that falsification was a very important component of a good scientific theory, is that it must be falsifiable. It must make claims that can be falsified. Following that, then we get some psychological theories that now can be justified according to the logical positivist definition of science. So we get Tolman's research on cognitive maps, where he had the rats learn to solve a maze, and then when he would put an unexpected roadblock somewhere in the maze, the rats knew how to get around the roadblock. They had never been trained to get around how to get around this roadblock. So how in the world would they know how to do it? A pure behaviorist explanation of rat behavior in this context would just say that their responses should be trial and error, and that essentially half of the rats would choose alternative pathway detour number 1, and the other half would choose detour number 2, right? But that's not what Tolman found, right? That the majority of his rats were choosing the better detour, the more efficient detour, suggesting that they had some knowledge and they were applying it to solve this problem. You know, it's an example of what he called insight learning, right? They're faced with a novel problem, and based on knowledge that they already have, they have some insight into how to solve it. This is clearly a more cognitive kind of process that involves internal knowledge that we can't see, but the rats are using it to solve this problem. And so now we get a more cognitively oriented explanation of this behavior that involves having this intervening variable between the stimulus and the response. There's something happening in there that we can't see, but it must be there, right? This is not just pure stimulus-response behavior anymore. And Hull is doing a similar thing here with his hypothetical deductive approach. He talks about all these various intervening variables such as drive strength and habit strength and incentive motivation, and how all of these things can be quantified and then can be combined to calculate a reaction potential, and that using a reaction potential you could calculate the probability of a given response. But there's a whole long line of intervening variables here that would create this mathematical kind of an equation of behavior. And then next up is Skinner, who really is more of a radical behaviorist. He doesn't like the idea of intervening variables or logical positivism or any of this kind of cognitive stuff at all. In fact, he was a very vocal critic of cognitive psychology, as it emerges here in the next chapter. But his theories were still unique in the sense that he advocated for this idea of operant conditioning as opposed to the classical conditioning of Watson and Pavlov. So he created the Skinner box, kind of a modern version of Thorndike's puzzle box. But instead of talking about reward, which is a very psychological idea for Thorndike, based on satisfying needs and desires, here Skinner talks about reinforcement and punishment. Yeah, and these are just operationally defined terms. Reinforcement is not something that's rewarding, right? It doesn't satisfy a need. It's just something that increases behavior. It's something that's just an operational definition. Any stimulus that increases behavior is, by definition, a reinforcer. Any stimulus that decreases behavior is, by definition, a punishment. It doesn't matter what it is. It just depends on what the effect it has on behavior. We also talked about things like positive and negative reinforcement and positive and negative punishment, so make sure you can define those as well. Skinner took this kind of reductionist view that said that things that appear complex in behavior are not really complex, that they really can be boiled down to a sequence of simpler behaviors that have all been individually reinforced and then sequenced together into a longer chain of events to shape up a much larger behavior. Skinner was mainly a student of reinforcement. He didn't think punishment was very effective as a way of changing behavior, so he studied reinforcement. So make sure you understand the different schedules of reinforcement that he studied. So the difference between continuous versus partial reinforcement schedules, and then also the different types, like the ratio schedules, variable ratio and fixed ratio, and the interval, variable, interval, and fixed interval schedules. Know the effect that those things have on behavior, which one led to the highest rate of responding, and that was the variable ratio, kind of like the gambling stuff. And then also how variable interval created a pattern of behavior that Skinner equated to superstitious behavior. And we also saw some applied component to Skinner as well. So his various inventions, like the pigeon-guided bomb, the teaching machine, the baby tender, and then also some of his controversial social ideas, because he's a deterministic behaviorist. He doesn't believe in free will, and that means he doesn't believe that certain societal ideas like freedom and liberty and individual responsibility and the nature of the criminal justice system as a result of all of that is all wrong in his view, and that we would need a more kind of top-down, behaviorist-driven kind of society that does not recognize issues of individual responsibility and freedom. Obviously controversial for a lot of reasons. Last chapter here for this unit is chapter 14 in cognitive psychology. So the first thing that we did is we talked about another area of philosophy of science here, and this is Thomas Kuhn's ideas of scientific revolutions or paradigm shifts. And the term cognitive revolution has frequently been applied to what happened in the 1940s and 50s as cognitive psychology just kind of blossomed and took off as a big thing and replacing behaviorism. But we also thought about it as a situation where perhaps that does not actually meet the real definition of a scientific revolution in Kuhn's terms, because for Kuhn this means that whatever is new is a brand new idea that didn't exist before, and it so fundamentally changes the way in which the science is done that the older ideas cannot be done anymore. And with cognitive psychology, that's not exactly true. A lot of the ideas of cognitive psychology were really just a revival of old ideas that had been out of fashion during the behaviorist decades. And of course, there was no reason why behaviorists couldn't keep on doing behaviorist research. There was nothing in cognitive psychology that said that Skinner was wrong about reinforcement, for example. It was just that Skinner's theories were wildly incomplete as a way of explaining behavior, and that we would need to also introduce more cognitively oriented concepts such as stages of memory. And here we get Miller talking about the magic number 7 as a way of describing one of the stages of memory, short-term memory, right? And of course Chomsky's argument that language is one of these complex things that cannot be explained, and Skinner described it in terms of imitation and reinforcement, that you need to have the grammatical side, especially for Chomsky, is something that has to be built into the brain, has to be innate, and it's more of a top-down kind of cognitive process. And even also Lashley, who was in fact a behaviorist, but who had concluded by 1950 in his paper on serial ordered behavior that the behaviorist theories did not really work very well to explain a lot of sequentially or serially ordered behaviors like language. And so he talked about things like Spoonerisms, the weird speech errors made by the Reverend William Archibald Spooner, who really couldn't be explained in behaviorist terms. Now, there is at least one possibly revolutionary idea, something brand new that changed psychology in this era, and that would be the advent of digital computers and concepts related to information processing, like cybernetics, control theory, measuring information in terms of bits, and thinking about information processing in terms of bandwidth or bits per second. And we see the development of the idea of connectionism and neural networks, and how that has influenced things like modern machine learning, deep learning, deep neural networks. Fitts' law in the 1950s is a really simple but very compelling example of how concepts related to bits and bits per second can explain, in the case of Fitts' law, pointing behavior, right? A simple pointing task, but explaining it very, very thoroughly, right? Accounting for so much of the variance that we get one of our few laws in psychology. We also talked about the issue of artificial intelligence, right? That if we can develop these kind of cybernetic principles of information processing to explain human cognition, that we could also institute these principles on a machine, and that the machine would be doing the exact same thing at an information processing level that a human is, in which case we could achieve artificial intelligence if we could mimic that same degree of information processing, although there was some controversy about that basic idea.